Number 66 of the Piezo Shock Show. Today I'm going to be talking about preload and pretension, which you know is the process of putting a bolt through across your piezo rings in order to compress them. We know that's done for several reasons. Among them are to always keep the ceramics under compression. And the other reason is just to keep everything together. Because if you have tension in between two interfaces, that interface is going to come apart. Even if you have epoxy, there's only so much stress, tensile stress epoxy can hold before it then delaminates. So you need pretension on your ceramic stack. And when you actually do end up applying alternating stress due to oscillation of the piezo, you end up getting alternating stress, tension, and compression, but that tension is biased. So it's actually always in compression. It's just more in compression, less in compression. Sorry, more in compression, less in compression. More in compression, less in compression. However, what about this horn here? Like the metal components, like the back mass, obviously here you're going to see it's under compression because the bolt is behind it. It goes all the way through into the horn. But this top part of the horn, which sees the most, which is going to see a lot of strain, and it's also going to see significant displacement and tension. Does that need to be preloaded? That's a question for you, and I will answer that too. And the answer is no. There's no preloading needed for metal components because first, there are no interfaces in here. However, if you had an interface right there, like you had a tool at the end, that would have to be tightened down with enough pretension or compressive, adhesion that due to the oscillation and the stress occurring there would not be delamination. And that's actually why when you connect components like the horn and then there's other tools, sometimes it's multiple horns or pieces that you connect together. Whenever you connect, like some medical, for example, transducers have the base transducer, then you connect like a horn tool, which is actually sometimes quite long to that. And the actual connection point needs to be an antinode of maximum displacement. The reason why you want it maximum displacement is because there's not that stress and strain that's going to pull apart those interfaces. You're okay with high forces. You're okay with high displacements. You're not okay with high force or high stress because that's going to delaminate your or pull apart your interfaces, therefore you won't get the acoustic transfer you want. The other reason you don't need preload on a horn itself or on a metal component is because they're fine in tension. They don't have a problem working in tension. You could technically run this bolt longer down, and you could technically have some type of way where you do preload the horn maybe, but that's not going to be useful. It's not going to perform any different. Ceramics and interfaces do perform different under tension and compression. Interfaces simply just don't work under tension. Even if you have epoxy, it's not going to survive very long. And number two is what do we have? Metal components. They don't mind tension, unlike ceramics. So if you were to have your horn made out of a ceramic material, you would probably need some type of compression, but don't do it because it's not the right material for the job. All right, so you've been watching episode number 66 of the Piezo Shock Show. My name is Hussein Shikani. I have a business where I consult on ultrasonic transducer product development, including simulation, prototyping. I work with both new devices and also new technology which perhaps is going through an upgrade or a significant change where you need an expert to help troubleshoot and understand your next steps and work through them. All right, so I'll see you in the next episode.